Good morning. It's another very brisk morning in Sydney. If you remember in the last episode, we put up the partition wall, so the sliding partition for privacy and to close off the cabin. I did mention last time I was here that I had some concerns with the vinyl planking on the wooden arches. Because I didn't put any Sikabond on it, the panels keep falling off with the heat and contraction and expansion. So I am just going to secure those in with some screws. They're probably going to be hidden anyway, so it shouldn't really matter in the long run. But yeah, let's get started on that. Today I think we will reconnect the battery system up and put in the ventilation fan. I need to check some things with the electrics, so I will need to duck up to the hardware store to get some supplies. But yeah, hopefully we can get the ventilation fan in today, and then we can start on some other stuff. Okay, so I've just shut the doors because it's a lot warmer in here than it is outside. Insulation seems to be working really well. With the battery, so I need to reconnect the second battery to the main car battery. And also hook up the inverter and the power regulator and stuff like that. So if you remember, I made this frame for the first design that I had for this structural wall. So I'm actually going to reuse this as a leg frame for the battery system. So I'll put some housing on it so that it doesn't get excess damage, and I can mount stuff on top of it as well. I'm pretty sure I've got a spare piece of wood like this, the excess that was on there, that should be enough to fit. So I'll just measure that up and then make the framing. I've also got some hinges that I'll attach it to the wall. That way I can lift it up and work on it if I need to in the future. As I mentioned, these two are just offcuts from previous structures, so I'm not going to measure anything. It just needs to close off that battery area. I will put some supporting screws in here in this frame because I do plan to put the inverter and maybe the circuit breaker on top of this. So just to support a little bit of weight, it shouldn't need too much. there we go. It's not pretty, but it's functional. I don't need it to be pretty. It's going to be covered over with the bed anyway. Okay, let's add... No, let's hook up the battery. Actually, change of plans. We will go up to the hardware store first, just so that I don't have to redo it once I get the circuit breaker. So I need to get some cables and the circuit breaker switches. So I have an idea of how I want to lay it out. So we'll go grab that stuff and reconnect the battery after. Okay, I have just come back from the hardware store and got some electrical supplies, some cables, some new terminals, electrical tape and whatnot. Just before I hook it all up, I'm quickly going to explain how circuit breakers and fuses work. So they both do the same job, and that is to limit the amount of electricity going through the cables. That way, if your electrical device is faulty, it won't cause a fire. So here I have a switchboard mount which the circuit breaker clips into. This specific one also has a earth bar, which is why I got it, and I will be using the circuit breakers over the fuses. So with circuit breakers and fuses, they work in a similar way. So they both exploit the properties of specific metals, and so the previous owner did have some fuses. He didn't actually have it connected up, but it looked like he was going to. So with a fuse, basically there are two prongs, and in the middle there is a thin cable. So when you hook one end of your electrical device into it, like the positive cable, and then another positive cable is going to your battery. So that circuit is completed with that thin wire in between. So each specific fuse has a different rating on it to limit how much electricity that your appliance actually needs. So that tiny little cable running between the two prongs, it will snap when it's overheated, which will break the circuit. So if there's too much electricity running through it, then that metal cable running between the two spokes will heat up and expand, and it'll eventually just come loose, and there won't be any joining of the circuit, and that's what breaks the circuit. So that's how fuses work. The reason I'm not going for fuses is because you have to keep changing them if they do break out, and since I don't know if I'm going to be in the middle of nowhere without access to this, I don't want my water system to be completely reliant on this. So the pumping mechanism, I will need access to, and once the water tank is mounted, I won't be taking it off. Okay. Now, with circuit breakers, they also use the same exploitation of heat to break the circuit. So with a circuit breaker, there is a prong here and a prong here, just like the fuse, but in between it there is a spring. So when the spring gets too heated, it will also expand, and once it gets to a certain length, it will jump off the little mount that's holding it. So if there's too much electricity, the spring will expand, and then it'll push off the mount to break the circuit. And then to reset the switch, you push the button in and it will reload the spring back into the mount. With circuit breakers, so because it does use that heat contraction and expansion, you can't just flip it straight away. You have to wait like 30 seconds or so for the spring to cool down before it works. But it works in exactly the same way. It's just this is reusable, which is more practical for what I need it for. So yeah, that is how fuses and circuit breakers work. Okay, so if you remember from the other day, the previous owner did have a dual battery system set up, and there was this regulator in between the second battery and the car battery. Originally I was going to take all this stuff out and put it in a more better suited place, but in looking at the cable, there's not much slack that's with the current cable that's connected up to the car battery. I don't want to have to redo the car battery electrics, so I'm just going to use the current cable that's in there. It means that I need to put this further out, unfortunately, but it'll save me time and having to redo it, and the cables are pretty expensive themselves anyway. So I'm just gonna leave this as it is, but have it mounted up this way rather than actually I will put it down, because then I can use the space above for storage. Okay, I'm just going to be re-terminating these ends because they weren't held on very securely. Like this just fell off as I was moving the box. So I'm just going to re-terminate these and make sure it's held in tighter. Okay, so I have re-terminated the connectors and added a bit more insulation tape on. So this positive cable is running from the car battery into the regulator, and then the regulator is going out to this cable here, which will be connected to the second battery. So when you're working on the second battery, when we dismantled it, I did mention that the negative cable comes off first, because that's where the power actually comes from. So you're breaking the circuit there. When you're reconnecting it back up, you do it in the opposite fashion, because the black cable is the live one. You do all your work on the positive stuff, and when you're ready to go, that's when you connect the black one in. So we will hook up the positive side, and then we will add our inverter, and we won't add the solar power just yet because I still need to mount that, but I've got to build structures for that. So let's just hook up the inverter for now, and test it out and make sure it's working fine. Okay, so now that I've hooked up the battery system again, let's just test it and make sure it works. Okay, looks like the power lights come on. Yep, so that's all hooked up correctly now. I have power. Okay, so now that I have my power up and running, I will connect the the circuit breaker, and we will do some test runs on some lights because they're low powered. But I realized I actually need to go up to the hardware store because I forgot to get negative terminals. I only got the positive one, so I'd like to label them, and just so that if anyone in future does do work on them, they know which one's positive, which one's negative. It's for my best interest as well. So I'll just quickly duck up to the hardware store and get some supplies, and we'll continue on. Just one more thing, I did want to also double check to make sure that the regulator is working correctly. It was only one cable, so it should be fine, but I have turned on the engine, and you can see that the light is on. So it is working correctly. Okay, if you remember a few episodes ago, we did test out the electrical system, and we found out that the negative terminals was conducted by the body of the car. So all we had to do was to plug in the positive terminal into the battery, and we could use the car as the negative terminal. So I'm just going to double check that once more by plugging it directly into the battery. This is the positive side. And with the negative side, I'm just going to touch it on the metal. And yeah, you can see that the lights turn on. So the lights turn on when I attach it to a nail on the car. So we know that that circuitry is correct. So now what we have to do is to interrupt the circuitry that's there with a circuit breaker. Okay, I'm gonna go ahead and start wiring this circuit breaker. So what I'll be doing is taking the positive end of this light and hooking it into the top connector, and then the bottom connector I will be hooking it to the battery. Okay, so that end is attached to the lights, and I'm just getting an extra bit of cable. So once again, I have hooked up the positive end to the battery terminal. In between the positive cable, there is this circuit breaker. So between the lights positive cable and here, okay, sorry, let me start again. So from the lights, the positive cable is running directly into this circuit breaker. From this circuit breaker, there is a positive cable running to the positive terminal of the battery. So it's one line that's broken up by this. The negative terminal I will plug into the whole of the car, and the lights should go on. Okay, there we go. So the lights are on, so that circuit is complete. Now to test and make sure that this is actually breaking the circuit, I just need to flip this switch. Okay, so that shows me that the circuit can be broken just by flipping that switch. Okay, now I can't replicate a power surge without having a faulty device, and I don't want to do that. But I am just going to trust that this will work as it should. Yeah, so let's connect this up and set up our power system. Another question that you might have is, how do you know which circuit breaker you should get? This one is 8 amps. They vary from 8 to about 40, and you can find out, it depends how you're wiring your system. So with my one, I want a different circuit breaker for the different types of appliances that I'm using. So I'm gonna have one for the lights, one for the water system, one for the USB power, and another one for the 12 volt power. So the way you can work out how much ampage you should get is by having a look at the appliance that you want. So on the label it should say somewhere how many amps and what the voltage is to run that appliance. So when you have a look at that label, generally you would times it by 1.5. So a appliance like a light, actually let's use the water pump because I know what that is. So the water pump is 5 amps. So 1.5 times the 5 amps is 7.5. The reason why you want to times it by 1.5 is to calculate for fluctuations in the power current. So when you turn on an appliance, generally it takes a little bit more to switch on that appliance than if it was just running constantly. The same thing happens with like, let's say I have the faucet on really high rather than have it trickling water. You know, it's going to require more power to pump that water through at a higher rate than if it was just trickling out. So you know, when you first turn on a computer, you can hear that fan going really fast. That is caused by a sudden surge in the power before it switches on and knows that it needs to regulate the power current. So yeah, rule of thumb, 1.5 times what the optimal level is. I'm having a bit of trouble figuring out how this switchboard works. The circuit breaker attaches on like that, but in doing that it completes the circuit without actually going through the fuse, because this thing is made of metal. Let me figure out what is going on. Yeah, and I will get back to you after I find out how this thing works. Okay, let's recap what we did today. So we re-hooked up the power system and tested and make sure it was working fine. And we also discussed the differences between fuses and circuit breakers. We also tested out the circuit breaker to make sure that the theory was all correct there, which it was. I will go back tomorrow morning and exchange this series for the fuse that I have here that we've tested out with. So tomorrow morning, let's test out the new fuse box, the switchboard, and we'll connect up the ventilation fan as well. I did just test it out to make sure, because it's just out of the box. I did just hook it directly to the main power, and it does work. So tomorrow hopefully we can just hook it all up. Cutting the hole in the roof is a bit nerve-wracking for me, so I think I might test it out, cutting techniques anyway, on a bit of plywood before we actually cut into the metal. But yeah, Thanks for joining me today. I hope you learnt something about how electricals work. If you did enjoy this and want to keep following, hit the subscribe button there.